Hello class, I hope you had a wonderful weekend and you were well rested and you're ready to get back into the groove of things. Before we start, I decided that every week, I'm going to teach you a Korean word. Right, not only do you get math, you get Korean in your lessons. How cool is that? Once a week, I'm going to put in a Korean word. Today, the Korean word is hello. And how you say hello in Korean is 안녕. Now, I can look through your notes and I can tell that you watched it or not because you wrote this down in your notes. 안녕! Hello! Alright, so we got a little Korean in our lesson. But today, for math side, we're going to learn about scientific notation. Who knows what this is? Raise your hand. I can't see you, so if you raised your hand, I wouldn't have known. So anyway, scientific notation is when we write big numbers or very small numbers. It's just shorthand. It's kind of like when you write, for example, doctor. Shorthand for doctor is DR period, right? Abbreviations. This is like math abbreviation. So doctor's doctor, Mr. is MR, right? So let me give you an example of what I mean by this. Alright, so scientific notation is shorthand for writing really, really big numbers or really, really small numbers, right? And the reason we call it scientific notation is because a lot of scientists, they write really big numbers or really small numbers. For example, when you're looking at like a microscope, you know, like those little cells, these are really small numbers, and scientists aren't going to write 0.000. You know, they're not going to write all those small numbers, right? So they're going to write it in scientific notation. Or like if you're talking about going, say, this is Earth. It looks kind of funny, but anyways, this is Earth, and we're talking about the distance to the moon or something. We're not going to write all those big numbers. We're not going to write how far it is in every single digit. We're going to write in scientific notation to make it shorthand. Does that make sense? So you're trying to make a big number or a small number and abbreviate it. For example, this big number here. No one has time to write this big number all the time. You know what I'm saying? We don't have time for this. So we're going to write it in a shorthand version. So how to write in this in scientific notation is 3.4 times 10 to the 9th. And I'll show you how I did that, okay? So this number, 3.4 times 10 to the 9th, is equal to this big number right here, all right? And we could do that the opposite way. So say, for example, I have a really small number, 0.0, 1, 2, 3, let's see, 4, 5, 6, 7. Say I have this really big small number here, okay? I could also write this as 5.76 times 10 to the negative 8th. Now, since it's really small, we're going to have a negative exponent. Alright, I'll show you how to do this. Don't you worry. Don't you worry. Okay, let's start off kind of a small number. Let's start off with 700. This is what we call standard form, okay? So standard form is how you write a number now, right? You write the whole number. That's standard form. It's how you are used to writing a number. But I'm going to change that to scientific notation. So the general structure, the way a scientific notation is written is like this. This is the way it is written. Okay? So the way it is written is like this. You write the number, whatever number it is, it's a decimal, right? Hold on. So you write this decimal times 10 to the something power, okay? And this decimal right here has to be any number, a number between 1 and 10. So this number has to be a number between 1 and 10. Does that make sense? So it has to be a number between 1 and 10. For example, 700 is... the decimals are right here, right? Because 700 is 700.000. Now, if I move it here, the number is 70. It's not between 1 and 10. So I have to move it one more time. This number is between 1 and 10. It's 7, right? So we write it as 7.0 times. Since we moved it to the left twice, it's 10 to the second power because we moved it to the left twice. All right? So how does this make sense? Well, let's look at it. Let's look at it, right? So 700 is the same thing as 7 times 100, right? And 100 equals 10 to the second, because 10 times 10 is 100. We did that. Powers of 10. Remember? This is powers of 10. So that means that 700 equals 7 times 10 to the second. All right? If you multiply that out, it does equal 700. Is that making sort of sense? Let's do another one. All right, this number's kind of big, right? So we're going to change it to scientific notation. So the decimal's right there, and we're going to move it until it's between 1 and 10. Oh, another question you might have asked is, remember I told you this number has to be between 1 and 10? 1 and 10. It has to be between 1 and 10. Well, can it be 1? Yes, it can be 1, but it cannot be 10. Okay, so this number can't be, basically has to be a single digit number. It has to be between 1, 2, 3, 4, 5, 6, 7, 8, 9, but it cannot be 10. So let's go back to this example here. So this decimal's here. So we move it over. It's not between 1 and 10. Nope. 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 Yay! 4.9 is between 1 and 10. So we're going to say it's 4.9, and we're going to see how many times we moved it. We moved it once, twice, 3, 4, 5, 6. We moved it 6 times, so it's 10 to the 6th power. If we move it to the left, the exponent is positive. Okay, I'll show you what happens when we move to the right. The exponent will be negative because we're dealing with smaller numbers. Okay, we'll get to that next. Okay, say it's a small number like this. Then I'm going to move this until I get between 1 and 10 again. Nope, nope, yay! 4.9 is between 1 and 10, right? So we write 4.9 times 10. This time, this is a small number. So we know this is going to be a negative exponent. So it moved over once, twice, 3 times, so it's negative 3. Anytime it's a small number, right? Small number meaning less than 1, then it's going to be a negative exponent. So small number, less than 1, negative exponent. A big number will be a positive exponent. Alright, that makes sense, right? Because negatives are small, positives are big. Alright, so let me give you a try it, and we will try it together. I'm going to ask you some questions tomorrow. 1 second. Alright, try these two problems. We got a big number and a small number. Figure it out. Remember, one's positive exponents, the next one's negative exponent. Remember, powers of 10. Powers of 10. Your favorite number should be 10. Alright, see you tomorrow. Annyeong! It also means bye in Korean. It means bye and hello. Alright, annyeong!